You really can't talk about Accumulate's innovations without first talking about its predecessor, Factom. So Factom was launched around the same time as Ethereum, and it boasts about 40 patents in the blockchain space, making it one of the largest patent holders in blockchain period. Paul Snow, who led Factom and now oversees development of Accumulate as our CTO, is credited with inventing or pioneering many important tools we use today, including anchoring transactions to other blockchains, being the first blockchain to have a dual token model, and also creating a precursor to what Bitcoin now calls SegWit. So Accumulate improves upon Factom with an entirely new architecture and many new innovative features that power the Web3 ecosystem. One of the core features of Accumulate is its identity-based architecture, which refers to the organization of the entire blockchain around identities as opposed to blocks. In a typical blockchain like Bitcoin, transactions are hashed. Those hashes are organized into a data structure called a Merkle tree. That Merkle tree is put inside of a block, which is typically bounded by time or size, and these blocks are connected using the roots of the trees from previous blocks to make a blockchain, so to speak. But in Accumulate, every identity, which we call an Accumulate Digital Identifier, or ADI for short, is treated kind of like its own independent blockchain. What this means is that we have the ability now to partition our entire network based upon identities. So a transaction between ADIs is only going to touch things that are held in their respective chains. This means you can validate transactions between your ADI and other ADIs you interact with, and not have to validate transactions across the entire Accumulate network. And because you're only dealing with a portion of the network, you can fully validate your transactions on a simple device like a smartphone. And this kind of leads into our second innovation, which is linear scalability through parallel processing of our validator networks. Every ADI in Accumulate is assigned to a particular block validator network, or BVN for short. This works because every ADI is its own independent blockchain. Every BVN is a network of 10 Tendermint nodes, each of which can process about several thousand transactions per second. If we need higher throughput, all we have to do is just add more BVNs. At launch, and also demonstrated by our testnet, Accumulate will be able to do about 75,000 TPS. However, we can easily scale to millions of TPS if needed, because we have mechanisms in place to allow these BVNs to communicate efficiently. And this, of course, leads to our third innovation, which is synthetic transactions. So every ADI in Accumulate has its own state because every ADI is its own blockchain. For that reason, transactions that are routed to an ADI must be processed independently of all other ADIs in the network. Communication between BVNs becomes inefficient when multiple ADIs are involved in a transaction, because now you need to coordinate communication between every single BVN in your network. If we had, for example, 1,000 BVNs, you'd have to make n squared, or 1 million queries to settle a single transaction, which is not scalable at all. Accumulate's solution to this problem is to generate an additional transaction that performs settlement within an ADI. Transactions generated by the protocol in response to transactions initiated by the user are referred to as synthetic transactions. These basically provide each of the relevant BVNs with a balance of every ADI that is debited or credited an ADI within its own network. This way, a BVN doesn't need to query every other BVN in the network to verify the balance of an ADI that initiates a transaction. This process is coordinated by a much larger network of Tendermint nodes we call the directory network, or DN. If we imagine the Accumulate network as a wheel, the DN would be the hub, right in the middle, and every BVN would be a spoke. This hub and spoke model of communication requires 2 times n number of queries. So going back to our example of 1,000 BVNs, we just reduced 1 million queries to only 2,000. This is scalable, and it's one of the reasons that Accumulate can bypass the trilemma of scalability, security, and decentralization. Another important innovation of Accumulate is scratch accounts, which compress data by limiting its availability. If the owner of an ADI creates a scratch account, then all the transaction hashes that belong to that account are going to be pruned at regular intervals of approximately 2 weeks, unless the owner decides to store that data off-chain. While the transaction hashes are pruned, The root hashes are always saved on-chain. This gives any user with access to the transaction hashes the ability to cryptographically prove the validity of the data in a Scratch account by deriving its root. Since roots are indexed on Accumulate, a user can also obtain proof of the order of that data to make a time-stamped audit trail. The main use case for Scratch accounts would be any application where you generate a lot of data and you don't want to write all that data to the blockchain, which can be really expensive. So for example, you could save important events on IoT networks like temperature fluctuations. You can get rid of all your baseline data, but you can still prove to anyone that your baseline data was properly collected and in a particular order by cheaply storing your original transactions off-chain and then deriving the root that is permanently stored by Accumulate. The final innovation I'll talk about today is Accumulate's identity and key hierarchies. Every ADI you create, whether it's for personal use or enterprise applications, can be as simple or as complex as you need. You can put any number of sub-ADIs underneath an ADI, and your sub-ADIs can have their own sub-ADIs all the way to infinity. So for example, your bank could have an ADI with the address ACC:// bank, because our ADIs are based off URLs. Your bank's ADI could have a sub-ADI called auditing, and this auditing sub-ADI could have a sub-ADI called manager, and so on. Also, every ADI and sub-ADI on Accumulate can have data accounts, token accounts, Scratch accounts, and so on. So this powerful feature allows a user to replicate virtually any organizational structure. Behind all these ADIs, sub-ADIs, and accounts lies the ability to make your security as simple or as complex as you need through Accumulate's key hierarchies. In Accumulate, each account has at least one key book, at least one key page within that key book, and at least one key within that key page. In the simplest case, your security would work kind of like a standard account you might use for transferring a small amount of tokens from one wallet to another. In the most complex case, you can assign managers to your ADI with a manager keybook that can automatically approve or deny transactions, kind of similar to how an ATM can approve or deny a withdrawal. You can give external ADIs the authority to do things within your account by inserting the URL of those ADI keybooks into one of your key pages. You can also do this entirely within a multi-sig framework where you define how many signatures are needed and how many keys each external ADI can have. And then one really interesting feature of Accumulate's authorization schemes is a prioritization of our key pages. You can have many different key pages within a keybook that have different priority levels. So a key page with a higher priority can modify the security of a key page with lower priority. This means that you have the ability to manage your keys over time. You can change your authorization schemes without making a new account. You can give somebody access to a multi-sig transaction or take their access away. Basically, you have the ability to replicate virtually any kind of financial transaction, and you can do all of this from a single account within the Accumulate wallet. So putting this all together, we have the ability in Accumulate to power both individual and enterprise applications. We can scale linearly as the protocol grows, to be flexible with regards to identity and key management. And by packaging all of this into our URL-based addresses, we can deliver Web3 technology with the convenience of Web2.